Here we are finding the area of a region. So the first question we have to answer is, are we going to do this with respect to x or with respect to y? It's tempting to do this with respect to x, especially because all of your curves, right, look like y equals something, y equals something, y equals something, right? So, that's a good indicator that you might want to do this with respect to x. However, with respect to x, you would need a top function and a bottom function. Now, clearly, the y equals square root of x is going to be on the top of the region. However, you have two different bottom functions, right? For a little bit, y equals 0 is on the bottom, but then all of a sudden the bottom function changes to this y equals x minus 6. So actually, in order to do this with respect to x, you would need to break it up into two integrals. You'd have to do top minus bottom here, and then another integral, top minus bottom here, and add them together. I'm going to try to avoid doing two integrals if I can. And you can, because actually this is a very good dy region. This region, if you were to draw a horizontal strip for any particular y in this region, that strip is always going to be bounded on the right by this line, which is the line y equals x minus 6, but you could just as well get x by itself there. That's the same as x equals y plus 6. So x equals y plus 6 is going to, that's going to be the right function. And then the function on the left is going to be, this curve right here, which is y equals square root of x, but you could also label that as x equals y squared. Okay, so notice, right, no matter where your horizontal strip is drawn there, for any given y in the region, it's going to be bounded on the right by the red line and bounded on the left by the blue curve. So I am going to do this with respect to y. Okay, the range of y, the bottom y is down here at y equals 0. That's pretty easy. The top y, we're going to have to figure out what it is by calculating that intersection point. So let's figure out the intersection of y, where is y squared equal to y plus 6? Okay, well that's the same as y squared minus y minus 6 equals 0. That's a quadratic that can be factored. That factors as y minus 3 times y plus 2. So either y equals 3 or y equals negative 2. We are looking for a positive y, so y equals 3 is the one we're looking for. And you can quickly check, right? 3, when y is 3, 3 squared would be 9, and then 3 plus 6 would also be 9. So it happens that the x-coordinate here is 9, but that's not really important here. What is important, since we are doing it with respect to y, is that y goes from 0 to 3. Okay, so the area is going to end up being the integral from 0 to 3, the right function minus the left function. So the right function is y plus 6, the left function is y squared. In general, it's a good idea to put parentheses around those, although here you don't really need them. So if we integrate, we'd have, right, the integral of y would be y squared over 2, the integral of 6 would be 6y, the integral of y squared would be y cubed over 3. That's going to be evaluated from 0 to 3, which, so you're going to do 3 squared over 2, plus 6 times 3 minus 3 cubed over 3. And I get 27 halves. So that's the area of our region.